Continuing with chapter 4 review, we'll start off with number 5 now. So find the y-intercept of the equation y equals 4/3 x minus 7/3. Recall that this equation is in slope-intercept form because slope-intercept form looks like this. The number that's being multiplied with the x is the slope. The number that's being added to the x or being subtracted from x is the y-intercept. In this case, we're subtracting 7/3, so that is the y-intercept. The y-intercept is a negative 7/3. Negative 7/3. What is the slope of the line y equals 4x plus 2? Same thing, this is in slope-intercept form. The slope is the value being multiplied with the x, so the slope is 4. What is the slope of the line on the graph at the right? So to find slope, we need to know the steepness of the line. To find the steepness of the line, we need to specifically look between 2 points that we can clearly identify the points that it goes through. Like for right here, if you look at the pencil tip, and I'm not sure if that's, it's somewhere between -1 and -2 for the x. So I don't clearly know the location there, or there I don't know the y value, or right there I don't know the x. So right here is a great spot to use. I know the coordinates here are -2, 2, and I know the coordinates right here are 0, 5. So slope is also known as the rise divided by the run. That's how we find our steepness. So I make a little triangle here showing the rise and the run. And the rise is the vertical component, so it's a positive 3 that I'm moving up to go from there to there. And the run is a positive 2. So rise divided by run. It's 3 divided by 2. And it's in a positive direction. Remember, positive slopes move this way, up and to the right. So it should be a positive fraction, which I have. Hypothetically, if we had a negatively sloped line, make sure that your slope equals a negative fraction. Sometimes when we build the rise-run triangle, we're focused more on just counting the squares. Well, when you count the squares and put the rise divided by the run, put a negative up there with the rise, because if you're going from left to right, your rise is actually falling. Question number 8, what is the y-intercept of the graph at the right? The y-intercept is where it crosses the y-axis, so that is 5. What is the x-intercept at the graph at the left? At the right. What is the x-intercept on the graph at the right? Well, if you look closely at it, it's actually kind of tough to identify. It's right there. It looks like it's, let's see here, -1, -2, -3. It's a little more than -3, and it's not quite -4, so it's somewhere in between. So I'm going to say about -3.5. We want to know that you know where the x-intercept is, and that's about where it is. There is an exact way to calculate it. We never practiced calculating it, and under final and algebra 1 here, you won't have to calculate. In this case, given a picture where it's not very, very clear, you won't have to calculate where the x-intercept is. We could in this situation, but we'll just approximate, and that's okay. What is the equation of the line on the graph at the right? So to be able to write the equation of a line in slope-intercept form, we need the slope and we need the y-intercept. And we calculated the slope was 3/2, so that goes in place of m. And make sure you put an x with that, 3/2 times x, plus the y-intercept, and the y-intercept was 5. So there's your equation of the line to the right. Consider the equation 2x minus 5y equals 10. Calculate the x and the y-intercept. To get the x-intercept, we want y to equal 0. If we go back to that picture where the line crosses the x-axis, the height or the y value is 0. So now we do that calculation. We do 2x minus 5 times 0 equals 10. Or rather, we do that substitution. We substitute in 0 for y, and then we solve this. This is actually super easy to solve because I would simplify first, and 5 times 0 is 0. So I really have 2x minus 0, which is really just 2x. So 2x equals 10. That means x equals 5. So the x-intercept is 5 because when y is 0, when y is 0, think about your coordinate pair x comma y. When y is 0, x is 5. And if you plot that point, that puts you on the x-axis. That's where this line crosses the x-axis. Similarly, to get the y-intercept, x has to equal 0. So substitute in 0 for x and solve for y. Now 2 times 0 is 0, so we really have negative 5y. Make sure you drop the minus sign down. That minus sign's essentially making the 5 a negative. So it's a negative 5. Negative 5 times what is 10? So divide by negative 5. So y equals negative 2. In other words, the y-intercept is negative 2 because when x is 0, y is negative 2. You plot that coordinate pair, that is your y-intercept. So once we know 2 points on a line, in this case we know the x-intercept where it crosses the x-axis and the y-intercept where the line crosses the y-axis, you can zing a line through those 2 points and correctly graph the line of that equation. Part B says write this equation so y is a function of x. That means isolate the y. Y is, if we translate that, y is means equals. We want to get y equals, and then there'll be an x over there. So we'll subtract 2x to start getting y by itself. Again, here, make sure you drop down a negative 5y. Y is not yet by itself. We need to divide by negative 5. The entire left side is getting divided by negative 5. The entire right side needs to get divided by negative 5. So when we simplify this, we have y by itself. Now the negatives here, when we have a negative divided by a negative, that cancels out or it becomes a positive. So we have y equals 2/5 times x. And then we need to simplify this fraction right here. 10 divided by negative 5 is negative 2. There is our equation of that line in slope-intercept form. Make a table of a few solutions to the equation written so y is a function of x. So it's kind of wordy, but I need to make sure that if we make a table, or that you can make a table to find solutions or points on a line. And let's use the version of this equation that's in slope-intercept form. If we review our equation or form types, that is standard form. This is y as a function of x, or slope-intercept form. Let's use slope-intercept form right there. So the second one, which is what I wrote down right here. Alrighty. This one's got a fraction in it, so I'm going to recommend that you use multiples of the denominator so we get whole number answers. You can use a calculator and get decimals or whatever, that's fine. Guessing on your summative you won't have a fraction here, but I can't guarantee it. So 2/5 times negative 5 is what I'm going to plug in for x. I want to see what y equals then. Meant to make more space here. So here we take 2 times negative 5, which is negative 10, and divide that by 5. So we get negative 2 minus 2, which is negative 4. We plug in 0 for x. Well, 2/5 times 0 is 0, minus 2 is negative 2. Last but not least, I'm going to plug in 5 for x. So 2/5 times 5 minus 2. 2 times 5 is 10. 10 divided by 5 is 2. But then I have to subtract off 2. 2 minus 2 is 0. So each of these inputs and outputs each respectively make a coordinate pair. So we have negative 5 comma negative 4, which is, I didn't put negative 5 on here. That would be somewhere right around there on this graph right here. We have 0, negative 2, which is right there. Shoot. Something doesn't feel good. Oh yeah, what doesn't feel good? Because why I said shoot is I started plotting the third point. I'm like, this is not making a straight line. The table is very, very good. Remember, if you use a pattern, if we have a linear equation, which that's all we've done this semester, if you have a pattern with the x's, you should have a pattern with the y's. So the numbers are good. I plotted -5, -4 wrong. Did you all catching that? So that should be right there. -5 for the x is right there. -4 for the y is about right there. Last but not least, plot the point 5, 0. So right 5, up 0. Let me talk through plotting the point so I do it correctly. So we have a straight line. That's good. We should, because this is linear algebra right now. Wait until second semester. Yeehaw. Graph the line. Oops, I got excited. I see the table and I just want to graph lines. So part D, graph the line in slope-intercept form. Done. Are the solutions from your table on the line? Oh, you know what? Well, so I kind of took those points and just started plotting them. If I used this instead to graph the line, I would plot the point -2 because that's your y-intercept. I'll do this in a different color. So that's right there. And then from there I'll go up 2, right 5. Boom! That hits right there, so that's good. That's kind of matching my solutions from the table. And check this out. We thought with this equation, really folks, all the equations we've been using on this screen right now are all the same equation. They're just in different forms. They should make the same line. We said our y-intercept was going to be -2. Boom. We said our x-intercept should be 5. Boom. This is jiving. And then if I take my slope, which is 2/5, and instead of going up 2 and right 5, I reverse that movement. I have to go down. I have to go down 2 and then left 5. That gets me this third point from my table. Bada bing, bada boom.